This lesson's for 5th grade. It's lesson 2 in our chapter over our dynamic Earth. In this lesson we will learn about plate tectonics and how the continents got to be the way they are. In this lesson you'll hear the following vocabulary: geologist, plate tectonics, magma, and fault. So let's get to it. Is Earth's crust moving? Well, yes, the continents on Earth are constantly moving. This was discovered about 100 years ago by German geologist Alfred Wegener. This is a picture of Alfred Wegener. What Wegener noticed was that there was something curious about the shape of the continents. That he thought that they looked like they joined together in a jigsaw puzzle. Before I get too far, let's backtrack. I said that Wegener was a geologist. A geologist is someone who examines rocks to find out the history of Earth and the Earth's structure. So anyway, back to Wegener's story. Wegener thought everything looked like a jigsaw puzzle. And as time passed, the puzzle pieces grew further and further apart. And the puzzle pieces, or the continents, are now in the positions that they are today. Wegener's idea of there once being a supercontinent called Pangaea, and then spreading apart into the positions they are today, is known as the Theory of Continental Drift. Well, at that time, scientists didn't know of any forces that could move continents. But over time, scientists found evidence that supported continental drift. They found a couple things. One thing that they found was that there were rocks, types of rocks in the mountains on the west coast of Africa. So you can see the west coast here. There are certain types of rocks. And those same types of rocks were also found on the east coast of South America. Well, if you look here, you notice that South America and Africa look like they might have fit in a puzzle piece. So the mountain could have been here, and they split apart, and there were rocks on those same sides. Because now, how could that happen? There's ocean all right there. That was one piece of evidence. Another piece of evidence was found in fossils. Fossils are the remains of things that were once living. Well, there was a fossil found of a freshwater reptile called Mesosaurus, which you can see here. This is Mesosaurus. Mesosaurus was also found in old rocks in South America and Africa. Well, Mesosaurus could not have swum through this saltwater Atlantic Ocean. It's just impossible. Again, that's a freshwater reptile. So, however, if the continents had been joined together, Mesosaurus could have traveled across the larger continent here from one side to the other through the freshwater rivers. So the conclusions that we can reach from that evidence, again, is that South America and Africa were part of that giant supercontinent called Pangaea. And over time they drifted apart, and the water that filled between them became the Atlantic Ocean. So again, all of that is part of Alfred Wegener's theory of continental drift. Again, that's just a theory, but it is supported by some pretty strong evidence. Well, the ocean floor between South America and Africa is spreading at a rate of about 4 centimeters, so that's 1.5 inches, every year. So if this rate of movement has happened for the past 130 million years, South America and Africa should be about 3,230 miles apart, give or take a mile. Well, that so happens to be the width of the southern Atlantic Ocean, the space that is between them. The ocean has filled up the space between those two continents, so there's some more evidence for you. You can see here, that's the width. So this was part of continental drift. Well, scientists have developed a second theory, and that is the theory called plate tectonics. Plate tectonics is the theory that's used to explain how forces deep within Earth can cause the ocean floor to spread and the continents to move. This theory can be describes the lithosphere as being made of huge plates of solid rock. Just in case you don't know, the lithosphere is a part of Earth's layer that is the crust and the top part of the mantle. Each Earth's continents rest on those plates, and the almost melted rock of the asthenosphere, which is underneath in the bottom part, it's the rest of the upper part of the mantle, and it's mainly melted rock. It's called the asthenosphere. That acts like a slippery surface on which the plates can move around. In the middle of the ocean, where the plates are moving apart, magma was being pushed from the mantle toward the surface. Magma is just hot melted rock. The upward movement of magma causes tension, so a stretch or a push, and that pushes the plates. So this push moves the ocean floor apart, and it separates the plates on either side of a mid-ocean ridge, which is an underwater mountain range. So since the continents are resting on these plates, and if these plates are moving, then the continents are going to move apart. As the hot melted rock reaches the surface, it cools and it builds up equally on both sides of the opening. The cooling rock forms the mid-ocean ridge and a rift valley. So a mid-ocean ridge, again, underwater mountain range, or rift valley is just like you would find a valley on land, but it's an underwater valley. It's the V shape you would find in between the mountains. The mid-ocean ridge runs parallel along the separating continents, and the ridge remains stationary or stays still while the ocean floor on both sides of the ridge grows wider and wider. So again, as they move and grow wider and wider, the continents grow further and further apart. So that is part of the theory of plate tectonics. Again, continental drift and plate tectonics are just theories, but the theories are supported with evidence. So we've talked about how the ocean floor can spread, and we've talked about, is the Earth's crust moving? Well, then how are mountains formed? Well, we learned a few minutes ago that tension moves Earth's plates. So what other ways can plates move? Plates can either be pushed into each other or they can be pulled apart from each other. When they're pushed into each other, like so, that force is called compression. Again, compression is just the squeezing or pushing together the Earth's crust. Whoops. Like so. Push together, compression. This makes folded mountains. An example of folded mountains are the Himalayan mountains. They formed millions of years ago as India and Asia were colliding into each other. The mountains grow about 0.2 of an inch taller every year. Okay, another force that can happen is when one plate rubs past another plate, like this. That's called shear. Shear is a force that twists and tears and pushes one part of the crust past another. And that sometimes happens in places called faults. Faults are deep cracks in the Earth's crust. Shear can cause Earth's crust to break along a fault, and that eventually can cause earthquakes. When this happens, one fault moves up and the other side of the fault moves down, and that produces these type of mountains, which are called fault block mountains. And an example would be the Sierra Nevadas in the western United States. So we've talked about the theory of continental drift proposed by Alfred Wegener, and how there was a supercontinent called Pangaea, and the continents drifted apart to the places they are today. We've talked about the theory of plate tectonics and how continents are sitting on top of plates on the crust and upper mantle that called the lithosphere, and how they've spread apart, and as they plates spread apart, the continents spread apart. And we've talked about how mountains form through either compression or shear, making folded or fault block mountains. If you have questions, please feel free to message me on Edmodo.